So now we are ready to conclude the lecture, and you know better than I do what you took away from this class, but please clarify this for you, what is clear and specifically what is muggy for you still. That is a very important aspect so that you can really define what you need to get a better understanding of the material that we covered today. I believe there was many things that we could have taken away from this class today, but only you know what you need to study more. I will tell you now, of course, what I intended to pass along to you with these lectures. So let's clarify that we are able to expand our equilibrium knowledge from 2D to 3D, and all we needed is to add a third direction. So I think we clearly understand that. And that enables us to actually calculate the forces in simple 3D structures. And by simple 3D structures, I mean what we had as a first example. So I can check that off, because if you understand the topics we covered in today's lecture, this was probably the easiest topic. And so we can check that off. You also understand that springs in 3D structures are really no different from springs in 2D structures, and that they are obviously not more complicated. So they definitely don't challenge us when we see springs in 3D systems in the future. And furthermore, we talked about the symmetry in structural systems so that we clearly understand what we can do to reduce or simplify our calculation efforts here. So I believe we can all check that off. And last but not least, we are now able to look at any non-symmetrical structure and calculate the forces from a real-world system, because we can translate the real world into a mathematical model, and we understand that we have three equations with three unknowns that can help us to solve these cable forces. So I can check that off and I be done with that as well. So now let's take a look at our homework so that we are ready to solve these problems in the real application. So here you see our problems that are upcoming, and surprise, surprise, the first one is an easy one, in quotation marks easy, of course. Easy is everything if you understand how to do it. And of course, our goal is to make these problems easy for you in the future, but also to challenge you, because right now they are not easy because we're learning this stuff, right? So here we have a first approach to solving this, and you can see that you can take advantage of the symmetry of the system. And you have a force given to you in that vertical rope, and there's one rope that pulls up and two ropes that actually spread the force over the x direction. And I think you can solve this fairly quickly if the things that I taught you today in the lecture made sense to you. Then this will be a quick and easy problem. Let's take a look at the next one. Now it becomes interesting, right? So now we actually have a completely random system here. There's no symmetry whatsoever, so you have to set up your equilibrium equations, and you also have to assume that this thing here is made from steel, and steel is just 7.9 times as heavy as water. That's what this here means, right? So you know how heavy a cubic meter of water is. So the steel cube is given with a volume A of something cubic meters. So let's say my A is 5, then I have 5 cubic meters. And I know how heavy 5 cubic meters of water would be, but 7.9 times would be the multiplier for steel. And then I can calculate all the forces here in the cables using kilonewton. And keep in mind that 1 cubic meter of water is equal to 10 kilonewton, right? So you can solve this problem as well. Let's take a look at the next one. Now it becomes really interesting, and this is where the challenge comes in. So here you now have a box with a certain weight given to you, and you have to actually calculate what force it takes here parallel to the y-axis that keeps the system in equilibrium. And note that you have symmetry here, but AB is equal to AC, and that will help you to find the answer. I wish you good luck with that. Again, this is meant to make you think. This is not meant to repeat what we did in the class. So please keep that in mind. Same is true for the last problem, where you have a planter given to you that has a certain weight and it's supported by this cable structure. And likewise, as before, you have symmetry that can help you to actually solve this problem. So for example, you see that from this anchor point here, or from this 0 point, D is just as far away as C and is just as high and just as long. So I believe this will help you. And here you have to reverse your logic, because you have to define the anchor point, the height of the anchor point B. That means you have to use geometric logic to hook this hook to the wall. But that concludes our homework overview, and I think you are now ready to tackle these problems. I wish you good luck with that. Please enjoy your engineering mechanics learning experience. This is real fun stuff. At least I tend to think so, because it is so visual and it reflects the real world. And hopefully you get some joy out of solving these problems. Good luck. Stay safe. I'll see you next time.